Please teach me how to solve less questions. Do not give me the answers directly. Solve it step by step.
Okay, I can help you solve this geometry problem step by step. What's the first thing you'd like to do to approach this problem?
I have no idea.
No problem. Let's start by looking at the given information. The problem states that AD is the height of triangle ABC and the length of AD is 12. We also know the values for tangent B and tangent C. Do you remember what the tangent of an angle in a right triangle represents?
Tangent is opposite side over the adjacent side.
That's correct. Tangent is the ratio of the opposite side to the adjacent side in a right triangle. Given that AD is the height to BC, we can see two right triangles formed, triangle ADB and triangle ADC. How can we use the tangent values for angle B and angle C along with the height AD to find the lengths of BD and DC?
Tangent B equals 3 over 2, which is AC over BC.
You're right that tan B is opposite over adjacent. In the right triangle ADB, the side opposite to angle B is AD, and the adjacent side is BD. So we have tan B equals AD divided by BD, which is 12 divided by BD. Can you set up a similar equation for tan C using triangle ADC?
Tan C equals AB over BC.
That's right. Triangle ADC.
And then
That's almost it. For angle C in triangle ADC, the opposite side is AD and the adjacent side is DC. So it should be AD over DC. Now we have two equations. Tan B equals 12 slash BD equals 3 halves. Tan C equals 12 slash D. C equals 2/3. Can you use these equations to find the lengths of BD and DC?
3 over 2 equals 12 over BD.
That's correct. So 3 halves equals 12 slash BD. How would you solve for BD?
So 3 times BD equals 12 times 2. So BD,
Yes, you can cross multiply. So 3 multiplied by BD. Correct. BD will be 24 divided by 3. And what does that give you for BD?
8.
Perfect. BD equals 8. Now, let's solve for DC using the equation for tan C. 2/3 equals 12 DC.
DC equals 3.
Be careful with your cross multiplication here. It should be 2 multiplied by DC equals 3 multiplied by 12. Can you recalculate DC from that?
I cancel 2 in both sides. So DC equals 3 times 1, which is 3.
You're almost there. The equation is 2DC equals 312. So what is 312? And then what is DC after dividing by 2?
I don't get it.
No problem. Let's go through it together. We have 2DC equals 312. First, calculate 312, which is 36. So now we have 2DC equals 36. To find DC, you divide both sides by 2. What do you get?
Why can't I just cross 2 for both sides?
You can divide 2 on both sides. The reason we do that is to isolate DC. Since DC is being multiplied by 2, dividing by 2 undoes that operation and leaves DC by itself. So if you divide 36 by 2, what do you get?
$18.
That's right. So DC equals 18. Now you have the lengths of BD and DC. The problem asks for the length of BC. Looking at the diagram, how are BD, DC, and BC related?
BC equals BD plus DC.
Exactly. BC is equal to BD plus DC. You've already found BD and DC. What is the sum of those two lengths?
26.
Correct. 8 plus 18 is 26. So the length of BC is 26. Does that make sense, given the options provided?
Option 5.
Yes. Option 5 is 26, so it matches. You've successfully solved the problem. You used the tangent ratios to find the lengths of the segments of BC, and then added them together to find the total length of BC. Do you have any other questions or want to try another problem?
How come tangent B is AD over BD, not AC over BC?
That's a good question. It's AD over BD because we're looking at the right triangle ADB. In a right triangle, the tangent of an angle is defined as the ratio of the length of the side opposite the angle to the length of the side adjacent to the angle. For angle B, AD is the opposite side and BD is the adjacent side. Does that clarify it?
How come AC is not the opposite side?
AC is not the opposite side for angle B because it's the hypotenuse of the right triangle ADB. The hypotenuse is always the longest side and is opposite the right angle. In the case of angle B, the side opposite it is AD.
Okay, thank you.
You're very welcome. Is there anything else I can help you with today?
No more, thank you.